It's integrated to 7.2.2. Just going to do a little bit more conditional probability, not a huge amount. This does come directly from the book for 7-79. So if you want the full-blown version of the question, you can go ahead and look there. So we know that first, every player is going to spin. The spinner itself is half red, half blue. If it lands on red, they reach into the red box. If it lands on blue, they reach into the blue box. Okay. So then we know that within the red box, there are certain counters. Then within the blue box, there are certain counters, and I have them drawn out here for you. So at this point, we want to go through and practice drawing a tree diagram. So we kind of took a break from that last time, but then we did it the time before that. So take this opportunity and see if you can draw the tree diagram for this situation. Okay, so double check yours against mine. You could have also done an area model for this, strictly because there's only two variables at play. So we're going to use this now to be able to answer some questions. So moving on to the next slide. All right, so here we go. Same tree diagram. Now we want to figure out what the probability of getting a cow counter is. So anything along the branch that has a cow counter in it is what we're going to use. So if I take a look at this, I know that I could have gone red and then gotten the cow, or I could have gone blue and then gotten the cow. So I need to go along those branches. So red and then cow is going to be a half times a third. Remember, we multiplied down the branches, or, so that's assuming you got red, or we could have done blue, which was a half times 1/10. So then that's going to give me 1/6 plus 1/20. And when I add those together, that's going to give me 13 out of 60. Okay. If you know a player got a cow counter, okay, so we know that that is given. They definitely got the cow. What's the probability that it had a red on spin? So this is a given situation. See if you can write it correctly and use the table to answer the question, or excuse me, the tree diagram to answer the question. Okay, so we're trying to figure out the probability of a red spin, knowing that they got a cow. So the cow part's going to go on the bottom. Well, the probability of getting a cow counter, we did in part B. So we can just use the 13/60 from part B above. And then probability of red spin and cow. All right, so looking back at the tree diagram, red spin and cow. That was the 1/2 times the 1/3. That's where my 1/6 came from. Now you might be wondering, well, how on earth did she just get magically 10 out of 13? Well, I used what I know about fractions, so I'll do a little bit of side work up here for you guys. So I know that I have 1/6. I'm going to use the division symbol with the 2 dots, divided by 13/60. I think when people see the division with the 2 dots, it triggers a memory for them. Remember that that can be rewritten as leave the first fraction alone, change it to multiply, flip the second fraction over. Now I know that I can simplify because 6 goes into both 6 and 60 evenly. 6 goes into 6 once, and 6 goes into 60 10 times. So then now I would do 1 times 10 on the top, which is 10, and 1 times 13 on the bottom, which is 13. That's where I got my 13 from. Okay, see if we can answer the next question too. So this is independence. Think about what we did last class and what formula you need to use. Okay, so I did probability of red spin and then red spin given cow. You could have reversed that though. So you could have done probability of cow and probability of cow given red spin. Either way, it's not going to work. So these are not going to be independent. So I would say, red spin and cow counter are not independent. Remember, not independent means associated. And then the only other thing that I have over here on part C, and this is really more if you're referring back to the book, is they have an area model written for you, but it's a little confusing. So I just wanted to kind of point out what they did here. They basically took two separate area models and decided to try to merge them. So on the very top here, you have the red situation with the chicken, the pig, and the cow. Then you have the bottom, which is the blue situation with the chicken, the pig, and the cow. That's where let me pull those numbers in too. So that's where the 1/3, the 2/5, and the 1/10 come from. It's just so that you know.